Welcome from Concept Clarity again, and this is your favorite physics channel. Welcome to all my friends, parents, and students. So today we are going to discuss about trigonometry. This is the second part of trigonometry video, trigonometry session. We are going to discuss about trigonometry ratios. Trigonometric ratios. Right. So let us proceed. Let us take a angle. Let us make an angle. Angle with what, sir? Let's just an angle theta here. Okay. Now, if I draw a line perpendicular here, and this is AB, and I draw another line here also perpendicular, this is A dash B dash, then we know that for similar triangles, what do we know for similar triangles? Ratio of corresponding sides are equal. I hope you remember class 10, right? What does it mean? Let us say this point is O. So if you take the ratio of OA by OA dash, this will become equal to OB by OB dash. Then this will become equal to AB by A dash B dash. This is similar triangle ratios. So now we can say, I'll move it to the next slide. I'll draw the triangle again here. We have point O. This is angle theta moved. This is AB. This is A dash B dash. So what we got based on similarity of triangles, you got OA by OA dash is equal to OB by OB dash is equal to AB by A dash B dash. So now we can say that OA divided by OB, right? OA divided by OB, which is OA dash B dash, okay, become equal to OA dash divided by OB dash. And we can also say that by AB by OB, AB by OB is equal to A dash B dash divided by OB dash, right? AB dash moves here. This is first, this is second, and then we can also say AB divided by OA is equal to A dash B dash divided by OA dash. So what is actually saying? If you look at O and OB, OA, this is one side, and OB is this side, OA dash, this entire side, and OB dash, this entire side. So it may mean that what it says that the ratio of any two sides of the right angle triangle does not depend on the size of the triangle. It depends only on the angle of the triangle. So let us define the ratios of the right angle triangle now. Okay, let us use the right angle triangle. We consider this as a right angle triangle. This is 90 degrees right angle triangle. This is angle theta. This is hypotenuse. Opposite to theta is opposite side, and this is the adjacent side. So now we have some important ratios. Sine theta is opposite divided by hypotenuse. I will call this as HYP. Okay, I will call this as OPP. I will now call this as ADJ. Okay, so opposite divided by hypotenuse, and cos theta is equal to adjacent divided by hypotenuse. And then you have another ratio called as tan theta. This is equal to tan theta is opposite divided by adjacent, is nothing but sine theta divided by cos theta. This is another way of representing tan theta. Now we'll see the reciprocals of these particular ratios. I'll clear this. We'll move to the next clean slate. Reciprocals. Sine theta reciprocal is basically 1 by sine theta, which is equal to cosec theta. So here the hypotenuse will be on the up, on the numerator, hypotenuse divided by opposite side. Then similarly you will have for cos theta. Cos theta can be reciprocal will be 1 by cos theta, which is written as sec theta is equal to same hypotenuse by adjacent side. Then tan theta reciprocal will be 1 by tan theta. This is called as cot theta, which is equal to adjacent, AD adjacent divided by opposite. Okay. So now they have understood the ratios and the reciprocals of the ratios. So now let us see some of the values for some of the common angles. And what are the common angles? The common angles are 0, 0 degrees, then another degree is basically 30 degrees. These are the common angles. 30 degrees, another common angle. Then another angle is 37 degrees, which is used extensively in physics. 45 degrees, in most of the problems you will see this 37 degrees. 45 degrees, 53 degrees, then you have 60 degrees, and then you have more after 90 also you have 80 degrees and all. I'll take till 90. Okay, then you have sine theta, cos theta, and tan theta. Okay, this is 0 degree. This is sine, tan, and cos. These are the values which you must remember, and this is an easy way to remember. If you know sine, you will know cos and tan as well. Okay, if you know sine, you will know cos and tan as well. Always you're starting with 0 degrees, so you always start with 0, right? All the numericals number system starts from 0, 0, 1, 2, 3 like that. So sine of 0 is always starting with 0. Okay, after that it goes on increasing. From 0 the max value is at 90, it is 1. Okay, for sine it goes from 0 to 1. For cos, what will happen? For cos it is reversed, it goes from 1 to 0. It goes from 1 to 0. For tan, what will happen? For tan, because it is tan is sine theta by cos theta, and 0 by 1 is 0, and 1 by 0 is infinity. Okay, these are the extremes which you need to remember. Okay, starts with 0, ends with 1. Starts with 1, ends with 0. 0 to infinity. Now let us do for sine of 30. Sine of 30 is half. Okay. So because sine of 30 is half, cos of cos of 60 will be half. We know, right? It goes from 0 to half all the way to 1. So it goes from 0 to half all the way. It will go to 1 this way also. It is going from 0 to half all the way. It's going to go to 1. Right? For 37, for sine of 37, let me draw the triangle here. A very brief triangle. I'll take one of the line as the right angle here. This is the right angle. Okay, and this is theta. This theta is basically, this theta is equal to 37 degrees. If this is 37 degrees, then this one will be 53 degrees. Okay, so so this will be the long side, short side, and big side. So sine of 37, remember that you are starting with 3, so this will be actually be 3, and then 5 will be here and 4 will be here. So sine of 37 will be 3 by 5. Okay, you have to always remember this triangle. Okay, opposite to 37 is 3, 3, 4, 5. 3, 4, 5. This is how you're supposed to remember. Opposite side is 3. Opposite side is 3. 3, 4, 5. Okay. So sine of 45 is 1 by root 2. This is the midpoint. So here also it will be 1 by root 2. Okay. If sine of 37 is 3 by 5, then cos of 53 will be 3 by 5. Cos of 53 will be 3 by 5. So sine of 53 will be how much then? Sine of 53 will be 4 by 5. Sine of 60 will be, remember there is something called as root 3. You will get root 3 by 2. Okay. So similarly here, cos of 30 will be hence root 3 by 2. Right? Cos of 37 will be 4 by 5. So now what is tan? Tan is basically sine by cos. Sine by cos. So you only take the numerator part of sine and numerator part of cos. So here you will get 1 by root 3. Here you will get 3 by 4. Here you will get 1. Here you will get 4 by 3. Here you will get root 3 by 1. Basically it's root 3 only. This is how you're supposed to remember. You can remember this triangle and you can also remember this triangle. So this is, if this is 30 degrees, then this will be 1, then this will be 2, and the last side will be given by Pythagoras. How you will get last side? 4 minus 1, right? This will be root 3. 1, root 3 and 2. Then you can plot all the values of all common angles. I hope this is easy to understand. I hope this is easy to understand. Interesting thing from here, what you notice is, let us go to the next slate, clean slate we will take. We have noticed that sine of 0 degrees is equal to the extreme value of cos of 90 degrees, right? These were equal. The sine of 30 degrees, you saw it equal to cos of 60 degrees, right? Then sine of 37 degrees, you saw it equal to cos of 53 degrees. If I have to draw the two triangles here again, I remember if this is theta, and it will be 1, 2, root 3 if this angle is 30 degrees. And there's another triangle. If this is 37 degrees, then this is 3, 4, 5. Right? This theta, right? So sine of 30 is 1 by root 3. Is it right? Sorry, sine of theta is 1 by 2, opposite by hypotenuse. What am I thinking? 1 by hypotenuse. So cos of 60 will be what? This will be the 60. The opposite, the adjacent angle will be 60. So cos of 60 will be 1 by 2, same thing. So you can use these triangles to easily remember. Okay. This expression can also be written as cos of 90 minus 0. We can write this as cos of 90 minus 30. 90 minus 30 is 60. It can be written this as cos of 90 minus 37 degrees. It's very interesting once you get a hang of it. One of the beautiful things, you'll enjoy trigonometry, right? So let's proceed. Let us see some of the few relations. Okay, let's see the next. Most of the aspects is considered. A few relationships which I wanted to remember is cos of 90 minus theta is equal to sine of theta, right? We already derived it from the previous slate, right? We have seen this. Then cot of 90 minus theta is equal to tan of theta. And then sine of 90 minus theta. Can I write this? Sine of 90 minus theta. We have not seen this, but we can effectively get it, right? We know that sine of 30 degrees is equal to cos of 60 degrees. And this can be written as cos of, if this is theta, sine of theta, then this can be written as cos of 90 minus theta. This will become, this is theta basically. So similarly, you can write cos of 30 is equal to sine of 60. So this can be written as sine of 90 minus 30, right? If I call this as theta, right? If I call this as theta, 90 minus theta is 60. So 90 minus theta, right? Which is cos theta. So that was cos theta. This is sine 90 minus theta. So I'll revise this. I'll say cos of theta is equal to sine of 90 minus theta. You can write it this way as well. So these are the various expressions you can derive based on already understood values. Okay, you can form n permutations of whatever from Pythagoras and trigonometric ratios. So Pythagoras, you already know Pythagoras, Pythagoras. How you spell Pythagoras? Pythagoras. Pythagoras theorem states that if these are the sides of the triangle, this is A, B, C, then A square plus B square is equal to C square. This is Pythagoras theorem, right? So from Pythagoras theorem, a very interesting relationship can be derived. So you can say a by c the whole square plus b by c the whole square is equal to 1. And a by c is what? If I take this side as theta, a by c is cos, b by c is sine, is equal to 1. This is based on Pythagoras theorem and trigonometric ratio. This is one very important formula. So with this we close the second part of trigonometry. We will be covering more aspects of trigonometry ratio in the subsequent session. Until then, subscribe, like and share. See you.